Okay, so that's quite a huge majority, but we'll need to go through it very quickly. But first, very quickly about me. I don't work at Rike. I work at kiwi.com and I lead small application security team there. I'm also OWASP Czech chapter leader, so we organize these meetups here in Czech Republic, in Brno and in Prague. There should be 4 events every year, so in case you are interested and you haven't been on one already, definitely come. We are also looking for speakers. And I also do some bug bounties in my private life, so that's why I will be talking about it today. So very quickly about agenda. First, we will speak about very quickly what is bug bounty and what it basically gives to the company. Common bugs in bug bounty, which can be automated, and then the automation itself. So we will focus on some scripts or in some platforms which can help you with this automation from both defensive and offensive side. It's sometimes very similar from both sides, but we'll get to it shortly. So first, what is bug bounty? We will show you an example of Facebook's bug bounty program. So the one most required part is that company publishes a VDP, vulnerability disclosure page. This I would encourage everyone in terms like what you are representing your companies here. Definitely, if you don't have one, submit it. It makes a job much easier for people which find bugs in your software accidentally, and they know that they can report it to you without you suing them. So please, if you don't have vulnerability disclosure page or security.txt file, publish it. And in case you want, you can extend it with some scope, like some in-scope target domains or applications, some rewards that would basically create bug bounty program out of vulnerability disclosure page, and some rules, like in example of Facebook, you are forbidden to test against Mark Zuckerberg account because there were some takeovers. And then hackers come, hack the target, and they basically just report findings to you. You pay them and fix it, and everyone is happy. The best thing about this is that you pay only for the valid bugs, so it's a totally different model from pen testing, where you pay for the time. In bug bounties, you just pay for the findings, which might be better, might not, depends on how hardened you are. Here you can see example of report on HackerOne platform, report to Shopify. I use this example often because it's one of my favorite bugs where Andre was able to escalate to full root access on all instances in one Shopify project just using one web SSRF bug. So in the end, it's win-win because companies improve their security and hackers can hack on target of their choice, and the best part is that it's still legal. There are also bug bounty platforms. I will just very briefly mention them. It's basically startups or right now major companies which try to push bug bounty to more companies, and they provide you this platform with support to enable you to do bug bounty program effectively. The advantages of it are registered hackers, a web platform for triaging of reports, a private option of private programs where you invite only dozens of hackers instead of publishing it open to the wild and then hoping that nobody will break your service. You will also get some guidance, and optionally you get the dedicated triage team, which will help you to go through the issues which hackers submit to you. Examples are below. There is also one Czechoslovak startup doing this, if you didn't know, Hack Trophy. But I can definitely recommend any of them in case you would be interested. So let's get to the main topic. Let's very quickly go through the common vulnerability classes and see if they can be automated. So first, like very classic one, which was in OWASP top 10, like a long time in top 3 list, but in 2017 it fell to the 7th place, I think, because of the frameworks. Do you think this can be easily automated, or can you automate finding of XSS at scale across multiple applications with different layout, with different frameworks? What do you think? Hey, I don't think so. I wasn't able to do that, and I don't know anyone who would be. There are some attempts, but in the end, it's still a very manual process, so we will not focus on that one. What do you think about SSRF? Does everyone know what is SSRF, by the way? Please raise your hand if you don't and you would like to hear about it. Okay, so SSRF, it's basically when you make server of the application, make request from their host. So the server itself will make a request to some endpoint. This means that the server, of course, is in some internal network, and then you can access the internal network or the local interface of the host itself. Or you, in terms of cloud providers, you can also access metadata endpoint, which can give you some juicy information, as you have seen in the example of report before here. Basically here, Andre with SSRF escalated to the root on all instances. But this is also a thing which can be automated at scale because it requires manual testing and going to the application deeply to find the functionality where they accept the URL and they, like, I don't know about any scanner which could do this automatically and reliably at the same time. Okay, what do you think about this third one, object storage misconfiguration? If you know what is object storage or what are S3 buckets, then you will most probably know that you can enumerate those at scale. You can very easily go through all of them and see if they are vulnerable or not. So we will focus on this one mostly, but not only on that one, also on the broken authentication, which is just a fancy naming for no authentication mostly. Leaked secrets, and security misconfigurations. So the source of this data is in the HackerPaved security report from HackerOne. Okay, so object storage misconfiguration. What is object storage? Does everyone know it? So do you know what is AWS S3 or Google Storage? Most of you does. Let's just recap it very quickly. It's just managed FTP used for attachments, static files, logs, backups, everything. You just put data there and it scales and you will just pay more and more and more and more because it can scale unlimitedly. It looks like this from the console, so you can upload some fancy get images to the S3 bucket, and then you can list the bucket contents, so to list all the images which are there. And here you can see that there is also some secret dog image, which you probably wouldn't like to leak to any third party. So what can go wrong? How can we leak the dog? Well, it turns out that AWS S3, and not only AWS S3, allows you to set public read, write, list, and write the bucket ACLs, which means that you can essentially take over the bucket. Just you basically specify that the previous owner doesn't need access anymore, and I will just like take it over for me. So you can just cut people off and take everything from it. So AWS gives you quite some responsibility. Defaults are safe. Defaults are no public write, no public read, but defaults can very easily go wrong if you give people power to do so. So just give you example, how does it look in console? Or actually through the HTTP API. So you can just curl. Okay, you can just curl the bucket. Every bucket has this unique name, unique DNS record, where you can list it. In case it's set as a public list, you can just do it without any authentication. It will just list you the contents, and then you can get the secret dog. You will get something like this, which is probably not the thing you wanted the people, like third-party people, to know, especially when they are doing some vendor assessment on you. Of course, it's not only dogs and cats. Basically, like most of the major companies, maybe not most, but a huge percent of major companies suffered a breach caused by misconfigured AWS S3. So here you see that Verizon, Accenture, Viacom, NSA, which is the fun part. Like not even NSA can get the permissions correctly. and also other US military agencies which leaked their secret data on misconfigured S3 bucket. And you are asking, what's the root cause of this? Like this checkbox right there in the UI, just like some junior DevOps guy will join the company. Someone will want to have some documents from some specific S3, and he will just go there. He will think that it's a good idea to do this, and suddenly you are leaking everything you have in the bucket to the world. So how to automate the, yeah, there is a warning, but the warning wasn't really there quite some years ago when this was like a huge hit. It's already old news, I would say. AWS has finally woke up after years of security researchers telling them that like it's not only users' responsibility doing this, but it's also yours because it also damages your reputation as AWS. So they finally started to do some proactive measures to help people understand that they do not want to leak everything to the public. So even a junior user should be able to understand that this is not a good idea. So the topic was automating bug bounty. How can we automate this? Well, turns out this is old news, as I said. There are public indexes which are scraping AWS S3 at scale, and they have millions of files and more than, I think now, this is like old number, I think now it's around 400,000 buckets. I'm not sure about the number, but it's a huge amount of buckets which are indexed in this nice queryable service which you can just buy access for and query for, I don't know, like etc shadow or anything you will think it's a good idea to query for. But you can also automate on your own. And from defensive side, it's quite easy because you see all the buckets which are misconfigured. And in most of the consoles, it's quite easily understandable which buckets are listable by public, which buckets are misconfigured. Finally, it wasn't like this 2 or 3 years ago. And you can also use tools which are monitoring these policies and alert you in case someone will misconfigure the bucket. So AWS config is one example of such on AWS. And Google Cloud Security Command Center is free service from Google, which is also doing this. It's monitoring all the buckets ACLs and basically just sends you an alert in case someone will misconfigure it. From offense, you of course don't have this very nice access to console. Otherwise, you wouldn't need those buckets in the first place. So you can use tools like GoGetBucket. You can either use the indexes or you can use tools like GoGetBucket or similar. The problem is that this is old news and most of the buckets were already picked up by other researchers. Like this was, on bug bounties, this was hit like 3-4 years ago and people were making like 20,000-30,000 a month just scanning buckets. But that's gone now and we need to somehow do it better, right? In case we want to continue it. So what can we do? We can either optimize discovery or we can check out other providers. Like AWS is not the only cloud provider in the world, right? Even for some companies it is. So optimizing discovery. We can use DNS instead of HTTP. Before it was very easy because AWS sent you different DNS response for invalid bucket name and valid bucket name. So you could just like query DNS records with mass DNS tool, and it's very efficient, very quick, and then you just pick up the results and go through some more deep enumeration. You can also use custom and adjusted word list to the target. So in case they are French, you can use French words. You can use head method in case you really need to use HTTP instead of get, which saves you quite some performance. And you can also check all the permissions. So if you check the tools which are out there for AWS, many of them are checking only listability, which is the thing that lists all your bucket contents. But that's not the only permission which you can misconfigure. You can set your buckets as writable publicly. You can set your buckets with writable ACL or ACP, as it's called in AWS, which is essentially even better than listing, and most of the tools weren't checking for that. maybe because it's dangerous, because the only way how to check, in case you don't have read ACP, is to try to overwrite it, which means that you will take over the bucket, and that's quite destructive, and it's not really like nice to do this. So wouldn't recommend to do that. In the tool I made for buckets, I called this YOLO option, and it's by default turned off. So this is some diagram which you can use for the S3 enumeration. Just very quickly, before it was possible to enumerate it just based on the DNS response, like if you get the response or not. But right now it's fixed. And the factor which you can still use is TTL. It's not that reliable, but it turns out that AWS returns much higher TTL for buckets which are not existent than the buckets which are existent. So you can still utilize this, but it might stop working at any point. And you can also check other providers. So let's check how are others working. So AWS, they allow you to set publicly read permissions, and write permissions. But now there are many, many measures which they took to prevent you from doing the stupid things. It's not 100% effective, but it decreased the amount of buckets a lot in the wild. Google Cloud, they also allow you everything to do with bucket, but instead of the simple checkbox, you actually need to write like all users instead of just ticking it. So it's, I would say, a bit even a step further from the secure usability point of view. Azure doesn't allow you to do public write, for example, or all those permissions thingies. And they even have some machine learning add-on which can detect compromise of the bucket, but I haven't tried it, so not sure how it works. There is also DigitalOcean Spaces. They have okayish warnings, but the fun part which I found there and reported to the bug bounty program is that if you set list through the API, in the UI it still shows you as the bucket is secured and everything is cool, but the bucket is listable in the end. They told me that it's just like UI issue and we don't care, so go away. And there is Alibaba Cloud, which doesn't allow you public list, which is the most dangerous and prevalent permission misconfiguration, which is surprising. I spent like 3 hours trying to find for the endpoint which would list it in case I would set it public, but it's just not there, not even through API. So I would like clap to Alibaba for doing this because it's, I think, really cool and there is no real use case for public list. And there is Oracle Cloud. Yes, they have cloud. The UI is not the most user-friendly, I would call it, but the very nice part about Oracle Cloud is that it's like super difficult to enumerate valid buckets. Like it's nearly impossible because you need to guess the account name and the bucket at the same time, and that's just way too difficult. Like there is from n+n combinations, as in case of Azure, you have n times n, and that's like in case you are speaking about millions buckets, then you are just like, I haven't even tried enumerating Oracle buckets, to be honest. So that's all for buckets. But buckets aren't the only thing which we will be talking about, even if it seems so far. I will also very quickly go through the issues which I described in the beginning. So first, broken authentication. Those are examples from HackerOne where there is a huge amount of reports which all their point is that someone went to this URL and have noticed that there is no authentication, or that the authentication allows any Gmail account. And as you may imagine, some of them might be pretty severe, as in this case, they misconfigured Jenkins instance to allow any Google account and paid 15K for that. One more example from Pornhub, where they forgot to secure Elasticsearch, and we don't know what was in the Elasticsearch, but everything was downloadable by everyone on the internet, so it might be already compromised somewhere on dark web. Uh, and this is just a very few examples. There are lots of open source application which doesn't provide you with good out mechanism by default. And people just deploy it, put it on production, or put it externally visible instances, and suddenly you have a vulnerability, and you don't even know about it. You can automate discovery from black box point of view, from the attacker point of view. You can enumerate the subdomains and the IPs via OWASP AMAS, which is quite cool tool used to scan certificate transparency and like 60 other sources and provide you with a list of subdomains and IPs for the given target. White box, again, it's quite easy. You just go to your DNS provider and dump the records. Or you go to your cloud provider and you dump the IPs of your machines and you scan it. Then you just make a screenshot, for example, with Aquaton. Aquaton works really nicely in the new version. And you can put it to Docker, iterate over all the assets, check out all the screenshots, maybe check only those which are responding with 200 or 301, etc. And you just check if you haven't found any new issue or any unsecured instance. To be like realistically secure and confident about your public exposure, you should be doing this regularly and you should be doing this continuously. So in case you, for example, notice that some service started responding with 200 instead of 401, you should probably get an alert about it, right? So that's one additional good tip how to check your public exposure more. There are also leak secrets. This is like a huge topic again. Everyone is making huge money on this and one is talking about it. Snapchat again here, paying 15K just for a single GitHub token leaked in a private repository, in a public repository of a user from Snapchat. So they were just scanning also private people, scraping some services like for marketing, and then scraping their GitHub profiles, and they found the token and got a 15K for that, because the token actually allowed everyone to access the whole Snapchat organization. So the impact is what matters in bug bounty, and here you can see the severity was 9.8 CVSS, so the impact was there. There is a really cool research, like it's so popular that there are even academics doing research about this. There was this really cool research, how bad can it get, where they basically, guys from North Carolina State University were researching GitHub and were scanning GitHub for 6 months. And they scanned every single commit. They developed a technique to scan every single commit with few API keys. And they scanned every single commit for new secrets. And they scanned all data sets of GitHub, archives. And they were looking just for very specific 11 high-impact API keys for services such as AWS, Google, Facebook, Twitter, or Stripe. And they developed a system which was also triaging the validity of their findings. So they were really able to tell with confidence that this token is valid and this like has these permissions. And their findings were quite, I wouldn't say surprising, but scary, because they found that there are thousands of new and unique secrets leaked every single day. And we are speaking only about these 11 high-impact API keys, not about the hundreds which are not scanned. And that Trufflehog, which was like the state-of-art tool for the open source researchers finding secrets in GitHub, detected only 25% of the secrets they found with their engine. So that was quite scary finding, and they cooperated with GitHub to improve the token scanning service. And now GitHub actually allows you to integrate, you as a third party can ask GitHub, like, please, this is my pattern of token. Like, for example, Slack token starts with XOPZ or something, and they are of certain length. So you can tell them this pattern, and you give them like, yeah, in case you find any token in public repository, please just invalidate it on this endpoint. So I think these researchers were like took a huge part in this happening on GitHub. In case you are interested, you can automate discovery via Trufflehawk, GitRob, GitLeaks, which is, from my experience, the best one because you can combine entropy and regex, which can help you filter out the false positives. And there is also Shgit, which tries to replicate what they've done, the researchers, and it monitors the GitHub in real time. And you can actually go to the hosted solution and can just search for the first secrets there. There are also CI logs. Like, there is so many secrets in CI logs, and so many CI logs are public. Also, you can embed in an application, especially mobile or Electron ones. Here, 7K just for one token in one version of Electron application. And you can forget files on web servers, secret files on web servers. So here I will tell you the story of AssetNode, which is one of the tools which I mentioned in the end. They are basically doing this continuous monitoring of your public exposure. So they were monitoring subdomains of Slack, and they were searching for the newly created .git files or some .env files, some private files which aren't supposed to be there. And they were scanning this every hour. After a few days or a few weeks, they got an alert about a new .git folder on one of the Slack QA servers. And it turned out this was a Git repository of Slack web application, which was 1.6 gigabytes with over 300 hard-coded secrets. And it looks something like this. And they were speaking about it on the Catch Me If You Can talk, which I really recommend watching. There are more vulnerabilities like this from them. And I have to say, it must have been really terrible job to rotate all of them. Like, they also feel very sorry about the Slack engineers rotating 300 secrets. So you should also scan for this ideally, because you don't want some random DevOps guy. In the end, it turned out to be like a random DevOps guy going to the server, and he needed to debug some on Slack web application, and he thought it's a good idea to clone the repo in the root of the web server, which it wasn't. Okay, so I'm already running out of time. Should I speed it up or should I continue? Okay, thank you. I'm terrible at keeping my time promises regarding talks, so really sorry about that, but I will try to keep it quick. Security misconfiguration. So this is like a very broad vulnerability class, like a new class or old class actually, like it's in a WASP top 10, I think. And for example, it can be Django debug mode or debug mode on any of your frameworks. In Django, they thought that it's a good idea to help developers debug their code by dumping all of the environment variables of the server to the dumping all the environment variables from the server to the output of the 500 error which you caused to the application. After some version, they started to validate based on the regex, so it cannot contain secret, it cannot contain password, it cannot contain token, I think. But the sanitization, of course, isn't perfect. And one server of Facebook was running old version of Sentry, which got, I think, there was like, debug mode enabled. And when they dumped it, they were able to retrieve secret key for the Sentry, which used old version of Django, which used Pickle, like its unsecure deserialization for storing cookies. So when they knew a secret key for cookies, they could craft a malicious cookie which would execute the code through the insecure deserialization. In the end, it turned out to be some sandbox environment on Facebook, but they still got 5K for it, which is pretty nice. And this is one more tip, which is already old one. It's like 6 months old, which means that all bug bounty programs have this gone. But you can share your Google Calendar via, you can share your Google Calendar publicly. Many of you might not even know. Many of you know because they share it. In case you share it, be very careful with it, because there are many details shared in your event details. So you can have links to Google Docs shared via link. You can have some passwords, maybe. and many different things shared in the agenda, which should remain secret. And of course, it's very easy again. It's just ticking one checkbox in the UI. So it's very easy to share it publicly, but it's very difficult for administrators to know that you have shared it publicly. So in the end, it turns out that this is like a very juicy topic for bug bounty hunters because they just go over all your emails they can find. They try if you don't have public details shared. And if you do, they will just scrape all the events, and you most probably have at least some sensitive information in your years of calendar. So in case you are G Suite admin, please check this out on your organization. Okay, so wrapping, yeah, there is also kudos to the talk, which I first heard about this technique on the B-Sides SF in 2019. So that's kudos for the Jerry Gambin, which is actually a founder of Intrigue.io, which is the project which I will share in the end. Wrapping this automation together, because all of the topics which I shared here, they all can be automated to some extent. Some completely, even with reporting to HackerOne, some partially, but they all can be automated quite quickly with some Python scripting knowledge. But it's not that easy. Like, if you want to automate like different vulnerability classes, and you want to do this at scale for like hundreds programs or at least tens, it's not that easy at all. And you might burn yourself a bit and spend lots of time without any return on investment. But there are some free solutions which can help. Laser Recon, which is just a series of bash scripts, but it's a good start. It basically creates you those workflows, as you have seen before, in bash. So it might scale, but I don't like bash that much. So I tend to over-engineer stuff. So I don't write many things with bash. There is Intricore, which I mentioned before. It's an open source Ruby monolithic tool which tries to abstract these assets, the graph subsystem. It's quite cool, even just as an idea. And there is Project Discovery, which is a new thing by the creator of Subfinder, which is a very popular subdomain enumeration tool. And it's currently in closed beta, but it might be a pretty go-to tool in the future. There are also paid solutions, because suddenly there were many startups trying to do the same thing, and some of them were quite successful, I would say. So Intricore or Project Discovery, they also offer a paid version, hosted one. And there is AssetNode, which actually was created by two really good, like top 100 bug bounty hunters in the world. So that one I can recommend. And also Detectify, which is a very cool tool, which was, I would say it was cool even before there was bug bounty. And the nice idea about Detectify is that they actually allow you to, as a researcher, you can submit a module to the Detectify. So if you have this new cool vulnerability and you want to do it at scale, you don't have to do it yourself. You can just give it to them, and they will run it on all their clients and pay you for per finding. So if you get 10 hits with critical severity, you get like $1,000. So that's a really cool idea, I would say. And there is Sweepatic, which is, I haven't tried this one at all, but it's just fun that it originated in Brno, so they might be also promising one. I won't be talking about my solution, which I made, because I told myself that it's a good idea to start, like when there is so many already existing solutions, I thought that it's a good idea to start my own, because they all sucked. But it wasn't that easy, and I cannot call it a success, even though it paid itself, but it wasn't a success as I wanted. And I used all the shiny technology which you can come up with, and I used all the shiny diagrams with everything, notifications in Slack, and everything was in GitLab CI, triggered from GitLab CI, Slack, or command line interface. It was very heavily inspired by some other tool, and called, I don't remember how, but it's in the slide somewhere. It was Bounty Machine. Yeah, I also recommend that one, but I took the wrong approach, I would say, because it was over-engineered, and I over-engineered mine even more. So I won't be giving you demo. If you want to see demo, I gave this very similar talk, but a bit longer one, at OWASP Brno some time ago. So you can watch the demo there, or you can just talk to me afterwards, and I can show you what I have. But I will share the lessons learned, because it was quite a learning journey for me. And start small, because I wanted to hack the world, and I wasn't even hacking my own testing targets. So start really small on 1 or 2 targets. Don't expect to earn money overnight. Like, you are not going to be a millionaire in 1 week and you start writing tool like this. You might not earn any money at all, because it's very, like, since you are paid just for the findings, it's just a game of chance, and it's sometimes might be frustrating that you get so many duplicates for which you don't get paid. But you will definitely earn some money in case you will sustain and you will really like keep the focus clear. And the most important for me, pick one thing and do it well. Don't try to do 10 things in average. Pick one thing, do it really well, and it will pay off. Keep it simple, stupid. In the end, I didn't need all this Kubernetes stuff and even like frameworks on top of Kubernetes, and I didn't need it. I just wanted to learn it, and it was a good learning experience. But I would, in case I would start it as a startup, which would be supposed my main source of income, I would probably not start with Kubernetes in one man. It makes sense for when you are like really a company, but in case you are doing a solo project or project with 1 or 2 people, you don't really need Kubernetes in most of the cases. And ideas are everywhere. Proper execution is what matters. Like, there are so many ideas in the world. Like, you cannot even keep up with all the new ideas which get shared. And the fun part is that the shared ideas aren't even sometimes worthy of starting on. But in the end, it turns out that you can pick like a 3-year-old vulnerability, or in case of James Kettle and HTTP request smuggling, as some of you may have noticed in the last year, he picked a vulnerability which was like 15 years old. It was known for 15 years. It was documented for 15 years. Nobody even knew the name of the vulnerability. And today there are, like, everyone is speaking about request smuggling in the AppSec world. So you can just pick an old vulnerability and try to find the new vectors for it. Thank you for your attention. And do you have any questions?